You may have relaxed in a natural hot springs pool or seen the Old Faithful geyser blasting out hot water into the air in Yellowstone National Park. But have you ever thought of where all the heat comes from? Well, it comes from deep beneath the surface of the Earth, and it's called geothermal energy, and we use it to generate clean, renewable electricity. This is how geothermal works. The heat from the Earth's crust warms water that has seeped into underground reservoirs. When water becomes hot enough, it breaks through the Earth's surface as steam. This tends to occur when the Earth's crust or plates meet and shift. At a point, taking advantage of geothermal energy was limited to areas where hot water would float near the surface. But as geothermal technologies begin to advance, we can leverage even more of these natural renewable energy sources. Engineers have developed a few different ways to produce power from geothermal wells into the ground. There are 3 different types of geothermal technology that are the most common. One of the most common geothermal technologies used today is a dry steam geothermal power plant. The steam underground flows directly to a spinning turbine that drives a generator and produces electricity. A flash steam power plant pump pushes a hot fluid into a vessel near the Earth's surface where it cools down. When it is cooling down, the fluid flashes or quickly turns into a vapor. Then the vapor arrives into a steam turbine where it powers a generator. There is just one more example that works differently than the 2 technologies mentioned previously. This plant is called a binary cycle. It uses 2 types of fluid. The first one is a hot fluid from underground. The second fluid is called a heat transfer fluid, which flows into a heat exchanger. The second fluid has a much lower boiling point than the first fluid, and so it flashes into a vapor with a lower temperature. When the second fluid flashes, it spins a turbine and drives a generator. The environmental advantages of this renewable energy source are substantial. There are very low emissions, small physical footprint, and minimal environmental impact. There are no disadvantages of geothermal energy hurting the environment, but there are very high installation costs. There is also a demand for a large yard for horizontal and vertical placement, as well as not having the choice for installation if you were to live in a city due to the small lot sizes.
Almost 1/3 of New York's carbon emissions come from heating and cooling buildings and heating water. Recently, New York took critical steps toward renewable space heating and cooling, announcing their 2-year rebate program for geothermal heat pumps. Although they have a higher initial cost than natural gas and fuel oil heating systems, they produce immense social benefits. Some of the benefits include reduced carbon emissions, reduced summer peak load on the electricity grid, and protect families and small businesses from gyrations in the oil and gas prices. Recently, the historic St. Patrick's Cathedral in New York activated a new geothermal heating and cooling system that will reduce the building's energy consumption by more than 30% and reduce CO2 emissions by approximately 94,000 kilograms. The future of geothermal energy holds pretty serious potential for clean energy and accounts for 1/6 of the world's power supplies today. Engineers have improved the binary cycle plants so that no emissions are released besides water vapor. As the technology is improving, the prices of these plants are becoming cheaper. Either way, it will be a part of renewable energy mix powering the world as fossil fuels are receding. Geothermal energy helps to push America toward energy independence and a clean, renewable way to meet our growing energy demand.